So good morning, guys. Sorry for the delay. So as we have discussed in the last class, so can you hear me? Can you hear me?
Yes, ma'am.
Yes, ma'am.
Right. So as we have discussed earlier in the last class regarding genetic algorithms, okay. So it is one of the machine learning algorithm, and it is used to get optimized for the result, and it provides very efficient and effective techniques for optimization. Okay, it is widely used today in business, scientific, and engineering circles. Okay. Okay. So I'll share the PPT. Screen visible? Guys, screen visible?
Y- Yes, ma'am.
Okay, right. Okay. So genetic algorithm is a method which is motivated by analogy to biological evolution. Okay, and the genetic algorithm searches the hypothesis space by generating successor hypotheses which repeatedly mutate and recombine parts of the best currently known hypothesis. So what will happen here means when we generate any hypothesis, when we get any output. So what it will do, the algorithm will generate the successor hypothesis from the hypothesis which we have got. Okay, so I'll show you here. So if you see here, so this is the input we have given, and this is the output which we have got. Okay. So what this hypothesis will do means from here it will give the successor hypothesis. What is the next output will be generated? Okay. In genetic programming, entire computer programs are evolved to certain fitness criteria. So this is the flowchart. So what we will do here, first we will start with some question, that is the problem statement. Okay, and we will create the initial random population of data that is called as organisms. Okay, and then we evaluate the fitness of that population. Okay, so after evaluating the fitness, fitness is nothing but which particular instance is correct, good to get the output, to select different solution, good solution. So for that, evaluation of fitness is necessary. Okay. Then after that, we will find the good solution with that fitness organisms, which we have taken from the total population. So if we execute any algorithm with this, if we are getting good solution, then we will stop. Otherwise, what we will do, we will repeat the process again. So in that process, what we are going to do, we reproduce and kill the organisms. That means unwanted data or something, anything we don't want that particular output. If you want to go for any new output, so likewise. Okay. So we will take new data and we mutate it and we repeat the process by selecting the fitness from that data. Okay. And we will apply some algorithm. Then if the solution is accurate, we will stop the process. Okay. So for this, in genetic algorithms, we will be using different types of general operators. So what are the general operators, genetic operators which we will use here is three different types. So what are these three? One is select operator, second one is mutation operator, third one is crossover. Select operator, crossover operator, and mutate operator. Okay. So here the first operator is selection operator. So what is the use of selection operator here? The main objective of this particular operation is that out of all the random population, so whatever the data which is there, from that data, we will take only few random data. Okay. After finding the fitness, then we will apply these three operators. Okay. So first, for selecting the data, so what we are going to do, we have to find two parents for getting the offspring. So by meeting these two parents, we will get one offspring. Okay, kotta data offspring. Okay, so that will be the highest fitness. So this is the use of selection operator. And in selection operator, we will be using different types of methods like priority wheel selection, Boltzmann selection, tournament selection, rank selection. So all these things. Okay. So out of all this, mainly we will be using uh, so we will be using priority uh, priority selection method, wheel selection method. So what is that selection method that I am saying here? While doing one example. So this is about selection operator. So now we will see the example. So there is one problem. Maximize the function f of x is equal to x square with x in intervals 0 to 31. So we are having the data x is equal to 0, 1, 2, 3, so on 31. Okay. So we are having 31 data points. Now what we have to do, first of all, we have to create the initial population. So what we have to do, we have taken data. For that data, we have to pick some random data. Okay. So from 0 to 31, I am taking 4 data points, 4 random population. Okay. So they are chromosomes or genotypes. So those are called as chromosomes. So chromosomes are individual instance and individual record ni మనం chromosomes అంటాం. So here, if you are having 100 instances, okay. So those are called as 100 chromosomes, 100 records. Okay. So I am taking 4 chromosomes here. So 4 instances, 4 records. So what are the 4 records? That is one is 13, 24, 8, 19. So everything, whatever the data which is there, that will be represented in the form of ones and zeros. Okay, so 13 can be written as 0, 11, 24 can be written as 11, and 8 can be written as 0, 1, 000. 19 can be written as 100, 100, 1. Okay, so what we are doing from the total data, we are just taking the random data. So here I am taking 4 data points, 4 records. Okay, so now after selecting the random population, what we have to do, we have to find the fitness first. Okay, so how we are going to find the fitness? First, whatever the data which you have taken, that you have to decode it into an integer. Okay, from decoding the data into integer, those are called as phenotypes. Okay, so what we are doing, whenever the data is there, that will be chromosomes or records or anything, those are called as genotypes. Once we select that genotypes, if we convert it into integer, those are called as phenotypes. Okay, so what we are doing now, we have to find the fitness. So for finding the fitness, first you have to decode it into integer. So here, uh, 0, 11, 0, 1 can be written as 13. But you know, 13 can be written as 0, 11, 0. So likewise. Okay. Next, calculate the fitness. So how you are going to calculate? So before going to calculate, just see the question. So in your question, you'll be having your function. Okay. So that is called as linear function. So apply all the data points in that particular linear function. Okay. So what is your function here? F of x is equal to x square. So now, whatever the data points which are there, you just square them. So what are the points? 13. Value is 13. So what you have to do? You have to square it. So after squaring, you will be getting 169. So likewise, for all the 4 data points, square the values. Okay. So 13, you will get it as 169. 24, you will get it as 176. 8, you will get it as 64. 19, you will get it as 361. Okay. Now, after applying the function f of x is equal to x square, what is the third step? We will reproduce and kill the organisms. Okay. So in your flowchart, what is the first one? Start. Start and then problem statement. Second entry, you have to take the random points. Third entry, you have to you have to evaluate the fitness point. After that, what you have to do? You have to reproduce and kill the organisms. Okay. So how we are going to do this? Just see here on the screen. I think you can see one table on the top. Okay. So how many strings you have taken? 4. How many values? 4 values. Okay. So what is your initial population? 0, 11, 0, 1, 11, 0, 0, 1, 0, 0, 1, 0, 0, 1. System cannot understand numbers, so it will be converted into zeros and ones. Okay. So whatever the data points which we have taken, that is converted into zeros and ones. Okay. So those are initial population here. Your initial population is these. Okay. Now you have to find the fitness value. Okay. So you have to find the fitness value, that is f of x is equal to x square, that you have written in the 4th column. Now what you have to do? You have to find the TI value. Okay. So what is PI value? PI value is nothing but your probability of that particular string. ఆ string అనేది ఎంత strong, ఎంత probable అని మీకు output రావడానికి. Okay, for getting the expected count, how much that particular data is giving you the highest probability. Okay, so for all these four values, you will be finding the probability here. Okay, so how you are going to find the probability? Just divide the fitness value by the total value, that is fitness value, the total of the fitness value. Okay, so 169 is your first value, square value, divided by 1170. 1170 is your fitness total value. Okay, so here you can see summation of I is equal to 1 to n, fj is equal to 169 plus 576 plus 64 plus 361. So that is equal to, you will be getting 1170. Okay. So 169 by 1170, 576 by 1170, 64 by 1170. So likewise, you will be getting 0.14, 0.49, 0.06, 0.31. So this is your PA value. Now what you have to do, you have to find the expected count. With this only, you can know which particular chromosome is having the highest probability. Okay, and the chromosome అంటే a particular data point, a particular instance, a particular record. Okay, so for that, what you have to do, n into probability. So what is n value? How many chromosomes you have taken? So how many random values you have taken? 4. That is equal to n value. Okay, now multiply that n value into pi, n into pi. So 4 into 0.14, 4 into 0.49, 4 into 0.06, 4 into 0.31. Okay, so now what will happen? You will get the values as 0.56, 1.97, 0.22, 1.23. So from these four, which one is the highest one? So second chromosome is having the highest value, that is 1.97. Okay, so in final expected count, string number 2, second row, it has maximum chance. Okay, it is having maximum chance of getting selected. So we will select that particular string. So why? Because it is giving us the highest probability. Okay, so దాన్ని మనం select చేసుకుంటాం. Next, one second guys. Okay. So till now what we have did. So here you can see. So which one is having the highest probability? Second string is having the highest probability. Okay. So that we have selected. So this is nothing but this is done by using selection operator. So this is the highest value which is having to select 1.97. Okay. So this is done by using select operator. So next, what we have to do, we have to find the next highest operator. Okay. Sorry, next highest probability string. So now what we have to do, we have to use crossover operator. So what is the use of crossover operator? So what is crossover? What we are doing here? Now we have applied selection operator. Okay. So here we have completed the first step of the algorithm. Okay. So in algorithm, we will be using three different steps. One is selection operator, crossover operator, mutation. So before these three, you have to find the fitness. Okay. So we have completed the first step of the algorithm. Now, what we have to do, we have to apply the crossover. Okay. What is crossover? Crossover says it can be 1 point or 2 point crossover or uniform crossover. So in 1 point crossover, what will happen? We will be selecting the pair of different strings and cut at some random position. Then those segments are snapped to form new pair of strings. So here you can see the example. So for example, so this is not related to the problem, to the example. Just for crossover, I am giving the example. So this is one string. This is one more string. This is one more string. Okay. So in first string 100 111 01. Next 101 010 11. So these two strings you have. ఈ రెండు డేటా ఉంది. దీంట్లో actually మీకు కొత్త డేటా రావాలి. So what you are going to do now, you are applying crossover here. So what you are doing, take the first three values of the first take the three values of the first number 100, okay, and then take the second number last digits and combine one number. In the same way, take the second number first three digits and first number last digits and combine the second offspring. So this is combining with first three numbers of the first string and the last five numbers of the second string. You will get one offspring. In the same way, first three numbers of the, so in this way. So in this way, you will be getting the offspring. So new data. So new data is formed. Okay. So if you take, this is one offspring. This is called as 1 point crossover. So in the same way, you'll be having 2 point crossover. So what is 2 point crossover? You're having two numbers. Okay. So 100 111 101 101 011. So these are the two numbers. You are applying 2 point crossover. Okay. So now what you have to do in this way and in this way. So first three numbers of the first number, first point, and middle two numbers of the second data point, and the last three numbers of the first number. You will get one new offspring. Okay. In the same way, these three are combined with these two and these two are combined again with these three. So you will get the second term. So likewise, you will be applying crossover. Okay. So here, select operator is used to probabilistically select a fraction of the best parents from the data to get the new generation point. Crossover is used. Crossover is considered probabilistically from pairs of the selected parents and produce two offspring by applying the crossover operator. Add all offsprings to get the parent new. Okay, so this is the use of crossover. So with the help of crossover, you will get new data. With the selection operator, you can find the new parent. Okay, the selected new parent. With that new parent, you will use crossover operator. Okay, so that we will see in problem. So now you are applying crossover operator here. Okay. So in this problem, now what we are doing here, we are applying crossover point. Okay. So it's string 2. If you see here, so in the previous table, 2, 3, see the 2, 3 numbers. In second string number, 11000 is there. In third, 01000 is there. So now what we have done, we have eliminated the third value. Okay. This third value is eliminated and we have inserted the new offspring here, new parent here. We have to select this one, అది మనం insert చేస్తాం. Okay. Third string బదులు మనం second string ని insert చేస్తాం. ఎందుకనంటే second string is having the highest probability and third string is having the lowest probability. So lowest probability ఉన్న దాంతోటి మనం highest probability ఉన్న దాంతోటి replace చేస్తాం మనం. Okay, so now replace the value with third. Second value is replaced with the third value. Okay, so same value we have written. So 1100 0 So we have written the same value. Okay. So here, since we need two parents for mating, so we instead of writing a string T, what we have did, we have written the third with string 2 in place of string 3. Okay. So in the previous slide, the total count of PI fitness value ఎంత ఉంది 1170. Okay. So next, after applying crossover, if you see here 7754, it has been increased. Okay. So in what we should get, we have to increase the value, fitness value increase value. Fitness value increase చేస్తే మనకి ఏదైతే అవుట్పుట్ వస్తుందో అది కరెక్ట్ అన్నట్టు. Okay. So here, what we have done, we have written the first value as it is, second value as it is. Instead of writing the third value, we have changed the third value with second string. Why? Because second string is having the highest probability. So we have removed the third one and we have included the second string with the third string. Okay. Now apply the crossover point. So what is 442? So 4422 is nothing but first four values. And here also first four values. From first point and second point I have taken first four values. From the second point, third point and the fourth point I have taken two values. అది మన ఇష్టం ఏదైనా తీసుకోవచ్చు. Okay, it's our wish to get the new offspring. Okay, so what I'm doing here, I'm combining first four points with the second point 4 points with the first one. మనకి ఏమొచ్చింది 01110 రావాలి. So that we have got here. In the same way, second row లో value ఏముంది 1100 ఉంది. దాన్ని ఫస్ట్ దాంతో కంబైన్ చేస్తే 1 తో కంబైన్ చేస్తే 11101. In the same way, 11 should be combined with this and 10 should be combined with this. So this is crossover. Okay. These are all what we have applied here is this is 1 point crossover only. We have not applied any 2 point crossover, uniform crossover like this. Okay. So here we have applied 1 point crossover. After applying the 1 point crossover, 01100, 11001, 11011, 10000, 0. So here 0 is there. Okay. So we have got new offspring points. So now what we have to do, again apply the process. We have to decode it into integer value. So this can be written as 12, this can be written as 25, this can be written as 27, this can be written as 16. Okay, apply the fitness value, fitness function. After applying the fitness function, you get 144, 25 as 625, 27, 729, 16 to 56. So what has happened? Our fitness has been improved. 1754. So we have got 1754. So what is happening here? If the fitness function is improving, this is our main objective of applying genetic algorithms. Okay. So we have to improve the fitness. Now, what we have to do, we have to apply the mutation operator. That is the third step. Okay. Okay. So apply the mutation operator. In mutation, mutation operator here it is applied to each child individually after crossover. Okay. So first we apply selection, second we apply crossover, third we apply mutation. So in mutation, the bits changes from 0 to 1 or from 1 to 0 randomly. If we select any particular offspring data in this, you can mutate any value. You can mutate this value or you can mutate this value. Okay. So after applying mutation, you have to see the fitness function. If it is increasing, that means our algorithm is working accurately, and whatever the output which we are getting, that is correct. Okay. So after applying the mutation, what will happen? If the fitness value increases, that is nothing but the algorithm is accurate. Whatever the model which we have developed is accurate. Okay, so this is the main objective of applying genetic algorithm. So here what we will do, we will randomly select the strings. Okay, any string, either this string or this string or this string, any string. Okay, now come back here to the problem. So what we are doing here, we will keep the strings second and third as it is. Why? Because we have applied the selection and crossover operator on these. Why? Because they are having the highest values. So if you see here in the previous table, second row and third fitness values are highest values. So what we are doing here, we have to keep the strings as it is. We should not change these strings. Why? Because we are getting the highest value. The probability of after applying the crossover for this particular data is highest. So what we have to do, after applying selection operator and crossover operator, if the points are having the highest probability, we have to keep as it is. Okay. The mutation operator should be applied to the other random variables. Okay. So other random variables are 1 and 4. So we will apply the mutation operator on these two. Okay. So now if you see here, so if you see here, the first offspring after crossover is 01100. Okay. So now what we are doing, we are picking up one value from this offspring, that is 0. Now what we have to do, if 0 is there, we have to convert it into 1 by applying mutation process, mutation operator. Okay. So what it will do, 0 will be converted to 1. So after applying mutation operator on this particular value, we will get the offspring, new offspring as 11100. Okay, and this value and this value will not be changed. This is written as it is. These two offsprings will be written as it is. Okay, and if you see the fourth offspring after crossover 10000. So what we are doing, we are applying the mutation operator on this particular value. Third value will apply. So third value will apply is manaki new offspring 10100. Okay. So these are the values after mutation. Now what we have to do? We have to convert it into integer. This should be decoded. So these are the values after decoding. Now apply the fitness function on this. Okay. After applying the fitness function, what has happened? The fitness function, summation of the fitness function has been increased. Okay. So what has happened? We have improved all the summation of individual fitness values. Now we can say that we got better results after applying genetic algorithms. If you are not getting the highest value, the fitness value is not increasing here. So whatever the values which we have taken, and the randomly select this mutate cheyడానికి crossover cheyడానికి అది correct కాదు అని. We have to do the other process, crossover for other values, mutation for other values. Okay, so this is about genetic algorithms with 3 operators. Okay, so you can see here crossover techniques, single point crossover, 2-point crossover, uniform crossover. So these are the 3 different techniques in crossover. In mutation technique, you are having point mutation. అంటే ఇక్కడ పాయింట్ ఏ పర్టికులర్ పాయింట్ తీసుకున్నామో ఆ పర్టికులర్ పాయింట్ ని మనం మ్యూటేట్ చేస్తాం. ఓకే, so here you can see. So here you can see single point crossover. So what we are doing, we are taking the individual values, initial strings here. Initial strings మనం first 5 తోటి సెకండ్ స్ట్రింగ్ ది లాస్ట్ 6 వాల్యూస్ ని కంబైన్ చేస్తాం. కంబైన్ చేస్తే మనకు వచ్చిన వాల్యూ ఇది. ఓకే, సో దిస్ ఇస్ సింగిల్ పాయింట్ క్రాస్ఓవర్. 2-point crossover అంటే we are using 2 points, one from the first string, 2 points from the second string, and we are combining these values. These and these are combined and we will get this particular value. Okay, if you are applying, if you are combining 11 and 0 1 0 1 and 1 0 0, you will get this particular value. Okay, so 2 points దగ్గర క్రాస్ ఓవర్ అయితే దాన్ని 2-point crossover. యూనిఫామ్ crossover అంటే ఎక్కడ పడితే అక్కడ crossover. Okay, so we are applying crossover here, here, for this point, for this place, at 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 this place, uniformly. Okay, so we will get new offsprings. These are the new offsprings which we will get, and we will apply mutation for this. Okay, next is mutation point. Mutation law, we will have only point mutation. అంటే ఎక్కడ పాయింట్ చేస్తే దాన్ని మాత్రమే మ్యూటేట్ చేయాలి మనం. 0 ఉంటే 1 గా, 1 ఉంటే 0 గా. Okay, so this is about the operators. So in the evening session, we will see one experiment and the other remaining topics. Yeah, Faridhi, Sandeep, are you there? Saikat, can you hear me? Anybody? Just send me the attendance. Okay.